Thank you for coming to the talk. This is basically just about logic bugs, so if you're kind of here for the MTE side, you're about to be quite disappointed. A quick introduction. Although it's only Joffrey and I up here today, this is actually the work of a whole bunch of other people at Interrupt, including Georgi and Mateusz. So yeah, we kind of got quite a big collective history of targeting mobiles at Pwn2Own, all the way back to 2012 when we were still MWR Labs. So this is basically the history of our exploits and what we're still doing to this day. The actual contest that has the mobile phones is the Toronto contest. It used to be Tokyo, and I think it's about to become the Irish contest. We'll find out soon. It has a whole bunch of other targets there, including home automation hubs, smart speakers, and routers. But this is just focusing on the mobile side. Cool. So it's probably a good shout to think about why we may want to do logic bugs as opposed to something a little more traditional. By traditional, I mean buffer overflows, use after freeze, race conditions, all of the really fun stuff that we love. Well, the truth is those bugs still exist. They are everywhere. They're just a lot more challenging to exploit because the defenders have done quite a good job adding all these great mitigations in. I think if any of you guys have looked at Chrome before, you may have come across Miracle Pointer and abseil hardening and yeah, just really effective ways of preventing us from using these bugs. Right, so the big plus is that you don't have to bypass any of them with logic bugs. When you find a bug, it's because it's how it was written. It's not corrupting anything. So it's a lot nicer to work with. So yeah, technically we do bypass MTE by just not using it. So it's not total clickbait. The downside is you can't just pipe dev random into a harness and get a bunch of logic bugs. You actually have to read the code, understand it, just to find the weird edge cases. As for mitigations for logic bugs, there aren't any. So yeah, you find a bug, you can basically just use it as it is. It's great. When we're actually targeting the devices at the contest, the way that we target it is very much down to the contest parameters. So I think most people tend to go the one-click route, which is where you give the device a URL, it gets clicked on, and you trigger your exploit that way. We've also done the NFC one in the past, but that was basically just an extension of the one-click by just loading a URL into an NFC tag and triggering it again. There's also the option of doing something a little more fancy, which is a little more remote through Bluetooth and Wi-Fi, but I don't think I've seen anyone do that so far, so maybe it's something we'll see in the future. Cool, so the main reason that everyone targets one-click is because it's just a little more interesting. You obviously get to target the browser itself, so on the Samsung devices, you've got the default browser as S browser. On the Xiaomi, you've got a Xiaomi own brand browser, and they're both Chromium under the hood, but outdated. They got some OEM specific niceties sprinkled in there, so that's pretty interesting too. But more importantly than that, you have what we call browsable activities. And these are activities in all the default installed applications on the device that are marked as browsable. And browsable means that it has a specific URI scheme, host, maybe a path, and if you click on a link with all of those together, it gets handled by this activity. So it's a great way to create a one-click chain. So here's an example from the Xiaomi App Store, just in the Android manifest. You can see that it's got the URI scheme set to me market. The host is h5.reverse.add. And if I click on a link, which is, for example, me market // h5 reverse add, that gets handled by this web reverse add activity bit of code. Right, so that's all well and good. We know how we can actually target interesting code through just a single link. But what are the kinds of bugs we're looking for? Well, the truth is they're all quite different. Logic bugs don't really have a set class. I think the closest thing we get to a class is just finding the same bug in multiple places. So one of the ones that we're going to talk about, and one that we kind of do quite a lot, is where part of the browsable intent that the attacker has created will get taken, treated as a URL, and loaded into a web view. And this web view will have maybe a JavaScript bridge associated with it. Now, a JavaScript bridge is something that's super great for us because it's a JavaScript object that's accessible from code running in this web view, and all the methods and everything are written in Java. So you end up being able to do a lot of really privileged operations. So for example, on app stores, you may have a web view with a JavaScript bridge and a method may be available for you to just install an application from the app store without any user interaction. So that's a great win for us. Sometimes you don't get to choose the full URL. You may have to do some weird logic-y stuff. So one thing that we see quite a lot for validation is regex being used to validate that a URL is trusted. So you find lots of weird bugs in those, which is quite cool. We've also seen them loading websites through HTTP. So if you just man in the middle of that, you just install arbitrary applications. So that's also quite nice. Occasionally, it's a little harder. You may have an actual whitelist of domains that you're allowed. So you may have to go find an XSS bug or an open redirect just so you can execute your own JavaScript within this web view. Another thing that we've seen quite a lot is the concept of an intent proxy, which is where components from the browsable intent will get taken and used to construct an entirely new intent, which can be used to target non-browsable activities. So you just massively increase your attack surface through that. Right, so I'm going to pass over to Joffrey to talk a little bit about the Samsung stuff that we've been doing.
Thanks, Max. So I'm going to talk a little bit about what we did over the past 10 years, what happened on the Samsung side, and how we popped them on the Samsung S22 and S23, and how it got way much harder. So first slide for the attack surface. So when we speak about all this attack surface, we don't really know what is coming from fresh phones out of the box. So this is the numbers, the real numbers. So you have 261 browsable activities, sounds like to me a lot. 12 NFCs, but usually, as you said, it just goes back into a URL being parsed, so not really interesting. But look at this amount of Wi-Fi and Bluetooth callbacks register that you can just trigger by, changing something on the network. It calls back something into a random application. Same thing for a Bluetooth. Seriously, it's a lot. It's such a lot of attack surface that we had to prioritize something. So we were okay, we need what, in the end of the day? We need to be able to do a remote code execution, so probably we need to install a package, right? So we need at least install packages, and sometimes you can get a win if you manage to steal a photo out of the phone. So it would be great to be able also to read external storage, which means extracting photo from the SD card, for example. So that's great, but it's still a lot, and IOSP is IOSP, it's hard. I don't like hard things. So I look at Samsung, and that's more okay. So you look at Samsung Galaxy Store, Samsung Galaxy Themes, Samsung My Files, Bixby, Game Launcher, and it's still a lot. So you look a little bit at what have been done over the past years, and Samsung Galaxy Store is really a nice target because it basically holds all the permission that you can dream about. You have everything. So that's really, really great. And when you have to look at the past entries, if you have people that are trying to exploit something for Samsung, usually, if you have more than 2 exploits, one of them will be the Samsung Galaxy Store. So let's look at it. The attack surface is kind of large, this large, but actually, it's 10% of what is really held by this application. So it's really large. So when it comes to reverse engineering, that's also a great target because Samsung, they have removed the symbols, so that's great. But they have left all the debugging strings, so you don't know what this function does. The log string will tell you. That's great. Really nice target. Super reverse friendly. So, you reverse everything, and at some point you discover this dispatching intent method that will just take this URI host and path, and it will just extract everything from what the user gave you, and will match it against a list of possible options, and will dispatch that into internal Java method. So this is the real attack surface. At this point, you just have to do what everybody does, and reversing everything, and trying to see what you can do. So this is what we will really talk about. First of all, a failure, as usual. Then a super cool bug where we were completely what the fuck. And then the final exploit we presented on 2023, which is, as you can see on the number of blocks, kind of harder, right? So the first one, Unfortunately, a failure, but with this amount of people looking at the same thing, it's kind of usual, you know. So when you look at this Samsung Galaxy Store, you always look for bugs that will be able to, you know, allow you installing an application and opening it without user consent. And when you search for these methods, you have these two JavaScript interfaces that are exposed through something called the MCS WebView activity, which is a web view that implements a Java to JavaScript bridge. And if you get a way to execute JavaScript, you can download an app without user consent and open it without user consent as well, which is pretty NRC to me. Obviously, as you can imagine, they don't want this JavaScript interface to be like available for everybody, so they try to restrict the URLs where it will be injected mainly. And the thing is, they tried for a long time, like 10 years, and it wasn't really quite good, but nowadays it is good, and you are forced to use the 3 URLs. So at this point, you're like, okay, what are my options? Like an XSS, cool. An Open Redirect will work as well because I get the JavaScript injected and then I can just move to something else that I own, cool as well. I can also pop the whole Samsung infrastructure, which I think they won't be very happy about. Even like the Pontu and ZDI people don't think they will be happy. So we are not gonna go this way, even if you'll see at the end, well, maybe. So Samsung Galaxy Store bugs in 2022. What we did, we have these 3 URLs, and we just do, you know, content discovery. At this point, I'm usually working on embedded stuff, and I end up doing pen tests, so my life has been weird sometimes. And it's a lot of static content. I just simply don't know what I do. I'm just like, okay, that's a bunch of things. And, you know, I don't like to explore random things like blindly, so as everybody, I automate everything with FRIDA, app interaction, I reroute the whole traffic, I collect the URLs. And I pass that into a web scanner, and I see a bunch of new URLs. I'm like, okay, here we talk. What do we have? This redirect.html1 sounds very nice to me. And I was like, okay, let's look at the JavaScript. We looked at the JavaScript, and we're like, not that nice in the end of the day. It's a lot of obfuscation, and, you know, can I get some clues in the application? Because in the end of the day, everything is meant to be used inside the application. So the application needs to know how to use the endpoint, right? So, you know, you decompile the APK, you look for things, and you get some clues in the APK, that's nice. You get some get parameters. One of them is obviously vulnerable to an XSS. You are really happy, and there's some guys that are disclosing that like 2 weeks before the competition, and you get very, very mad and sad, and you have a collision, and you need to suffer again. So here we go. First failure, no problem. Second try. Same URLs. The second one, image samsung.com, sorry. Again, a lot of static content, image multimedias and everything. Cool. And we were staring at that for a long time, and there's one very big red flag, like the big exception, like Samsung Instant Play, kind of new, really, really nice. Nobody really spoke about it already, so cool. We look at what it is, and this is meant to be like HTML and JS files that are loaded before you enter the tube mainly, and then you play your little game in the tube because you don't have network. So everything is supposed to be self-contained. That's great. You look at the JS dependencies, and everything is outdated. Sometimes, because these games are created by third-party studios. It's not developed by Samsung. It's like external people. A list of external people allowed. And then, yeah, you know, you can just audit the code quality. Sometimes it's really good. Sometimes it's less good. Sometimes it's arguable why they do that. And there's remote.js, like this remote.js, or like remote.js. What is it like? A remote JavaScript debugging engine. It can't be real. Like, no way. No, it won't never work. Like, there's an hard-coded token, and it connects back to like a real server where I just provide this token, and like it connects back to my phone. So no way. Still digging. Like, I'm connected really to this phone. That's kind of weird. Like, okay, can I call really download app? Yeah, it downloads the application. Can I really open the app? Yeah, it really installed the fucking application. That's really great. we go to the disclosure room, and at this point, the only thing we need to explain is there's a leftover GS debugger that exposes this really nice JavaScript bridge, and the token is hard-coded. So the only thing we have to do is initiate this connection, which means crafting the correct deep link in order to reach this nice game that is supposed to be played on the tube, like without any kind of internet, but still you have a remote GS debugger left over. Really nice. We disclosed that, and they were like, no, you're kidding us. Pretty much not. And here you have your RCE. Cool. 2022, a failure, then a very nice success. It was a great year. We moved on 2023, when we're like, here we go again, a matter of 2 weeks, maybe 1 month, it will be nice. It wasn't nice. It wasn't nice at all. It was like 3 months of pure suffering and navigating dead codes left over by the people from Samsung. And yeah, there are funny bugs, but just finding them is actually the real deal. But we know that instant plays, you know, they are not here for long, so here we go again. Let's look at instant plays. So instant plays, how they work, you provide this deep link, and you have a link parameter that is extracted from there, and it's loaded into a web view. So obviously, they don't want any links again to be like loaded into the web view, even if this one doesn't have like the cool bridge open app download app. It's a different web view with less privileges. So we look at the URL, and we're like, okay, they try to see if it's a secure URL, and if it's not, they get the secure version of it, and they proceed. Okay, let's look at the checks. So Max told you regex are fun. They try to see, does it start with HTTPS : colon. If it's not, they take everything before HTTPS : or whatever is here, and they replace by HTTPS : Can you spot the bug? This plus, I don't really like it. Can we have like a bypass maybe? What about this URL? It's not a secure URL. Okay, it returns true. Then they're like, okay, everything that is before : needs to be HTTPS : We get the version that is like the secure version of this URL. Looks great. Now, what about this one? There's nothing before, right? So it's not a secure URL. We absolutely need a secure URL. But this plus does not match it does not match the regex. Yeah, there's nothing before. So the secure version of this URL is the same URL. Lame bug for the moment. What can we do with that, really? Turns out, because there's so many implementations about how parsing an URL on Java, on Android, with some regex, and more, like at this point, you can expect some results at one place and other results in another place. So here, they parse this URL that passed all the checks, and they give it to URI parse. But this one is the Android one that is robust enough to understand that, yeah, : is actually a real URL. And yeah, if I do get lost on that, I will return this emg-samsungapps.com, which is the product version of the URL. Okay, so it passes all the checks. That's great. And now you're like, okay, this URL will actually reach the load page on the web view. And when the load URL just takes this URL, it's like, okay, I don't have the scheme, so it's probably an HTTP, right? Cool. And Android, they are like not dumb people. They are like, okay, here we go again. Someone is loading an HTTP URL. So we are about to make it by default refused, except if you really want to do that, you have to specify it into the manifest. Thanks, Samsung. We really, really love it. So like now, we can METM the traffic and inject our JavaScript code that is able to trigger this web view. And unfortunately, this web view is super boring. But can we pivot to something else? Probably. So in Android, you have this should override URL loading implementation that will be called every time you try to load a new page into a web view. And usually, they try to see if it matches few conditions, extract some parameters, and if it matches that, usually they're like, oh, this URL is actually maybe an intent, and I'm going to transfer it into an intent, and I'm going to fire it. That's great. So that's an instant game for sure. I need to launch another web view, which is like a proper way to escape. And we have like an intent proxy, not arbitrary intent proxy, but an intent proxy into Another activity that this time is a web view with a more interesting JavaScript bridge. This one, we have something called get device info. We had it like for the very first week of the research. And it leaks sensitive details about the phone, like phone MCC, phone NMC, okay, phone name, the profile picture of the guy. At this point, we were like, we don't want to go the full pen test road. ZDID, you accept this bug? And they were like, yeah, sure, why not? And I was like, can we really do something with this Samsung ID and Samsung leaked token? Like, it's weird. Turns out, you can. It's just a lot of finding the correct endpoints, but you can reconfigure the phone of the user. You can enable the geolocation tracking. You can get all the files from the Samsung cloud, so at this point, if it's just synced, yeah, you see phone of all this life. That's great. And I really wanted my RCE because it was too much work at this point, so I want an RCE, right? And yeah, you can push arbitrary application because you have the Samsung Galaxy Store that is enabled. So you can just kind of enable everything. Then you sign on the Samsung account of the guy. You kind of change his passport because you don't really know, but if you change it, then you know, right? And you push an application to the phone. And at point 2, I was like, that's great. However, this Samsung account, apparently the DI people, they had 3 different targets, and I was like, which is the one we are targeting? Yeah, we don't know. Okay, let's pop the 3. And there's 3 RCE that just appeared on the phones, which is pretty amazing for an XSS bug from my point of view. Thanks.
All right, so we're going to go on to the Xiaomi stuff now. Just like the Samsung, there's a pretty large amount of attack surface, 341 browsable intents, like 470 Bluetooth callbacks being registered. Like, if you want to do something remote, maybe take a look at the Xiaomi. To be honest, we didn't really look at anything except the App Store. The App Store was like the only thing we needed to actually look at because it was just an instant win. Obviously, it's a great target because it has the ability to install packages because, App Store. And it's also just not obfuscated, so it's super, super easy to reverse engineer. So we basically used the same bug in the same place and just bypassed patches for like a long, long time, like since 2019. So we're going to start with that one. This was actually found by Toby, who was at MWR at the time, is now at Interrupt as well. He found that with the URI scheme memarket and the host browse, you can actually use that to load URL into a web view and obviously JavaScript bridge with an install method to just install an application on the device. No user interaction. It's like the most basic thing. There is, however, some level of validation, and if you don't pass this validation, the URL doesn't get loaded into the web view with a nice JavaScript bridge. It gets loaded into something called light web activity, which doesn't have anything interesting on it. So what does it consider a trusted URL? Well, the first thing it's going to check is that there's no XSS in the URL. If it does, it will reject that. It didn't really stop us at all, so yeah, is what it is. The other thing is just it's checking the origin of the URL that you're loading. So something that's trusted is local files. And thankfully, the APK for the Xiaomi App Store has a bunch of HTML files included in it. So that's an option. Or you can choose a remote URL as long as it's part of like a whitelisted list of trusted and privileged hosts. So we're super lazy. Like Joffrey said, we are not pen testers. We don't like to look at, to do lots of like burp suite and is Diabuster still a thing? I don't know. So we opted for the local side. And Toby found that in one of the smallest ones, there was a great little XSS bug. Yeah, he found that this file, manual upgrade, takes a stringified JSON object from the URL through the get parameter manual upgrade info. It will then take properties from that and just dump it into the HTML that it's rendering to the page. So it's like XSS 101. It's like not even CTF worthy. Yeah, nothing really got in the way. It just this was basically the exploit URL. You know, we got the me market browse. We're selecting the URL as manual upgrade, and the manual upgrade info is where we have our XSS payload. So from there, we just did market.install and installed Droza from the App Store, and well, nice easy win. Despite the fact that the vendor was trying their hardest to make it look like there were no bugs and pretending that they already knew about these bugs, but really they just had copy-pasted reports from us. So, yeah, I'm not sour at all. You know. All right, forward to 2021. It hadn't actually been announced yet, but I was pretty sure the Xiaomi would be on the list again. So I thought I'd take a look at the bug, see how it was patched. They've added an XSS filter, which is pretty okay, but they were only applying it to the changelog property, which is the one we used at Pwn2Own. So I just switched that out for version code and same exploit. Unfortunately, I'm like super unlucky. So when the list of targets came out, Xiaomi was no longer on it. It's pretty obvious why. There was a lot of drama with multiple competing teams between the vendor. So yeah, probably a good shout to get rid of them for this. So I opted to go through their bug bounty, and they downgraded it because they didn't consider the app install to be RCE or code execution in general. So, yep. And that brings us to last year, 2023. Xiaomi has like suddenly appeared on the list again. Maybe they've paid for their sins or whatever. So I decided to take a look as well. Once again, to be fair, props to the Xiaomi security team. They did message me through the bug bounty like a week after the contest was announced, asking for a few more bugs. No response. Yeah, so they basically updated it a little bit more. You've still got the filter there, but now they're iterating over this JSON object, and if it's a string as a value, it will just run the XSS filter on top of that. But the good thing about JSON is you don't need to use a string as a value. You can use an array, and that's not going to be seen there. So once again, no XSS filter. Same file, same place. So yeah. Again, I am really unlucky. We ended up having 5 entries before us. I mean, it's pretty obvious why. Have you seen the bugs that we're using to just pop these devices? And one of them ended up getting us caught. So I think we may have collided with VCS Lab. We don't know the actual bug, but it was in the same file, so I assume it's the same bug. But what was kind of worse than that was by the second day, things were getting a little bit crazy. We noticed that the manual upgrade file had disappeared from the disk, but the app itself hadn't been updated. And turns out they'd recently, as in a week before the contest, added functionality to just remotely delete files from the device. So I can't fault it. Like, at the end of the day, they are a vendor. They are meant to be patching bugs. So that wasn't the big issue. What was a little more of an issue was the fact that they blocked the ability to install or update apps from their own app store in the contest area for the duration of the contest. So like no one was able to even run their exploits, which meant they didn't get any bugs. So just genius level thinking. I know I said that there are no mitigations for logic bugs, but like bricking all your devices is probably a pretty good one. So yeah, that was a bit of a failure. We had like 7 hours after we realized until our entry was actually due to be run. So we kind of came together, looked around, but were, yeah, just not lucky this time around. But it kind of made us a bit concerned about the whole, they've done this kind of thing before again and again, so it's very hard to actually give them a bug through something like Pwn2Own. So we were quite concerned about it, even just looking at the notes through ZDI and the fact that they are like delaying CVE notices for as long as possible. It's a bit ridiculous. So we've disclosed a bug to them, an exploit, and we're going to share it to kind of force some patches. So, Joffrey?
Yeah. Well, we are laughing about it, but back in time I wasn't laughing at all. And I was proper furious, so here it comes. We want to reach this market install web bridge once again. And we know from Max research that we can do that through HTTPS or file, because if you looked at the code, they were like, we allow HTTPS, HTTP, and file, and you pass the first check, you give like the HTTP URL, and they're like, oh, no, finally, HTTP is not a good idea, so no, we reject it. We are left with these two ones. So let's look at these is-URL match level checks once again. Remember, it's not obfuscated, it's not stripped, so all the names you see on these slides are the correct names, it's not a typo. So inside this get canonical path or absolute path, you have multiple checks to prevent someone to do a path traversal. So they are like, okay, first of all, if there's ... / probably they try to do something weird, so we block that. Then we have like encoding problems, double encoding problems, so single and double decoding of the URI, and we match the outcome with this wonderful get canonical path or absolute path, which is a proper way to get something that is properly done and break it really hard. So you have the Android get canonical path called inside, which can raise an exception if multiple conditions are met. One of them is you provide a very, very, very long URL, and it raises an IO exception. And they catch the exception, they're like, no, the user can't see the application crash, so this time we do a get absolute path, which breaks the whole thing of like blocking the path traversal. So we're like, nice recovery, dudes. Super easy bypasses. You double, triple, quadruple, how many times you want the URLs, and you're like, I'm a big brain, it will 100% work. It was a matter of like 1 week trying to do the right things, and we ended up into this load URL function of the web view, and that's the proper uncoded version of the URL. It's like, what the fuck are you doing? Like, I'm not gonna load that, go away. So like, okay, maybe starting by trying like the final point, what we want to achieve is a better idea next time. Big failure, no problem, let's move on. Local files, that's the only thing that has been really disclosed publicly. What about the trusted host? So trusted host, we look for an XSS, right? So you have these possible trusted hosts and privileged hosts, and from there, you can just do your little pen test magic once again. Same thing, a lot of static content, like really a lot, and a lot of 404. And directory discovery gave nothing once again. You decompile all the APKs, and you search for the URLs. You end up pretty quickly into this midrop helper index.html, except issues. You see where I'm coming, right? The XSS is this one, great. But multiple things. We have a DOM XSS, we tested payloads, obviously there's a WAF, and we got caught. So the WAF was detecting alert and script payloads, but if you do an image with no source and under our GS callback, it's get executed, so cool. But there's also like these XSS checks inside the application. So we have one bypass on the web server itself. What about a bypass on the application? As Max said, it didn't do shit last time, so why will do shit this time? Not really, because now we are able to really look at what they are doing, and they take a list of hard-coded possible payloads, and they take your URL, they remove all the white spaces. So mainly they concatenate everything, sorry. They look for like the URL, then the decoded version of the URL, and the double decoded version of the URL, which is the proper way of doing that. Unfortunately, that's a blacklist. So if you have one bypass, it's enough. Not a long blacklist also, from my point of view, but still a blacklist. So the previous payload was not working, so we were like, big brain move, we will add a with, and yeah, it bypasses the checks. Thanks, Xiaomi. And we were like, okay, here we go again. We triggered the market install, and Mipix is the really coolest store ever, super nice, except that it's absolutely not working. So we're like, what do you mean, like it's not working? We do that for like 10 years. It's supposed to work. Looking at the log, and we were like, okay, App installation is denied with install needs confirm log. Not really sure what I'm looking at. Let's reversing this extremely obfuscated app, because if it was obfuscated, it would have been another story, because this reversing thing was complex. But thanks to the name, we can understand that they did a mitigation. We said there's no mitigation. That's not true. There's a mitigation for this particular bug, which is calling a function virtually mainly without the user really using the store. So what they did is like they have a callback on the view on touch functionality of Android, which is really only triggered when you click the screen. You have to click the screen. So we're like, yeah, no, okay. We'll emulate a click from GS side. What is this bullshit mitigation? That's not a bullshit mitigation. You can't bypass it. At least we couldn't. So we're like, okay, that's actually getting interesting, and we have a real complete way of killing these GS bridge install things. So kind of sorry for the next years at Pontoon. This path is completely dead from our point of view. Happy for you guys if you look at that and you have a bypass. Please do. I couldn't. So at this point, we're like, okay, but that's a store. Maybe we can install application another way. And we reversed everything to find all the bugs, and mainly we ended up in few methods that we will just talk about in a few minutes that are able to install application, but they are not directly reachable. So how do we extend the attack surface? So we inspect the market bridge, and there's a lot of methodology methods that are accessible, but really not a lot of them are really useful. There's the install one that we can't use, the open app one that needs an app to be installed, so we can't use. But there's this load page that loads a page into the web view. And remember, I told you, usually they try to take a URL and they're like, is this an intent somehow? Can I transform it to like an intent? And if so, maybe I can fire this new activity. And this is exactly what's happening here. So we have a new intent proxy in the load page web bridge, which is really nice because when you get these kind of things, you also get access to the non-exported activity, which is by default trusted because they are not exported through like a browsable intent or something around those lines, which means there's less security. It's the case also on Samsung world. And here, mainly, they are like, they can't fire an intent that will reach this thing, so we can install application due to that. And it's not a bug, right? It's not a bug until you can reach it. And this is what an intent proxy inside the application gives us. The only thing is like, to reach this app detail activity inner, which is the one that is installing the application, you need to control a single parameter called start download inside the intent that you're about to run. And this parameter is checked, and if you provide it, they're like, no, you don't do that. We force it to false. So yeah, mainly we know the path we will take in few seconds, but we can't use this intent proxy because they kind of blocked us from doing it. So we need another intent proxy without any restriction. Does it exist in this application? Kind of. Remember this should override URL loading? I think we did that for like the past 2 years. Should override URL loading again and again and again. And it's always the same story because they take the URL and at some point they're like, can I do an intent with that? Yes, and they forgot that there's things that should be disabled, like this start download parameter, for example. So here you have a big call stack of a lot of should override URL loading embedded into other should override URL loading. And we couldn't even find them in the application. Like reversing that was a pure nightmare, so we just traced it with Frida. And one of them is not even inside the application. It's actually dynamically loaded like as a system APK. So yeah, kind of hidden. But thanks to Frida, thanks a lot, Frida, actually, because it would have been extremely annoying otherwise. We can see that there's this fallback web view client where they extract an URL from the control, from a parameter given by the user. And they're like, is this URL is like a Google Play URL? Not really, so you can bypass it pretty easily. They pass it into an intent and they fire this new intent. But this one, there's no proxy, there's no restriction. This is an intent proxy, but without restriction, so we can provide the start download parameter, which means we can install an application. And at this point, we had a working exploit that we wanted to show you guys. So yeah, the only issue is it got patched. So what is the patch? It was fun to laugh at the MIWAF, but we got caught multiple times. So at some point they were like, no, this XSS is gone. So the entry point is gone, and we were like really afraid because the whole payloads were in the web server logs for sure. But I worked at Qualcomm previously, and usually we don't really speak with like other teams, especially the pen test ones, and they don't talk to like us, at least at Qualcomm. And I think it's the same on Xiaomi because the whole exploit was there, but they patched only the entry point. So we just need, what, another bug, right? OK, let's find another bug. A new XSS, maybe. Or an open redirect would work. Or we are like inside a callback that is called every time a URL is loaded, right? So a simple redirect would work as well, which is really nice because it's easier to find. And it just needs to keep the URL parameters. The destination where we end up, we don't really care because this is not how we trigger the exploit. So we found this one pretty easily as well. It just adds this little slash after video. And important enough, it's ending up into like a 404, which is really annoying because the exploit is really unstable. If you are not quick enough, the web view kills itself and you don't get the code execution. So it's really annoying, but still it works. 2 days before the conference, something around those lines, there's this new redirection that happens where they're like, HTTPS is cool, but what about HTTP? Let's do HTTP in the middle for no reason. OK. And we're like, OK, show me things once again, no problem. But the exploit is gone, so why that? Remember, this HTTP is rejected in the isURL match level that is called inside the implementation of the callback when you load the URL. So it completely kills the exploit for absolutely no reason. So we're like, OK, here we go again. Like standard bugs in the end of the day, but keeps getting patched and patched and patched, and we have to work from like, I don't know, 10 to midnight. A bit annoying at some point. And we relooked at this attack surface is OSMatch, and actually we kind of missed something because when we relooked at that, it's not only like the domains that are load, but it's also the subdomains. And to be fair with you, we couldn't find another redirect, and we didn't want it to do like another XSS because redirects are better. And we were like, oh, yes, OK, there's more. 5 minutes later, we had this one, which is the real one we will demonstrate. And this one is actually way better because we don't end up into a 404, which means the exploit is 100% stable. And there's this little video that is the backup if it fails, which I truly hope won't fail. And this is the exploit. Yeah, it's coming. Where is my mouse? OK. So this is the phone. Mainly what we do is we spawn a local web server where we forward all the requests on a special port to a Python web server, where you have this totally not a virus link. So that's a one-click attack surface. You ready? Get apps, installing the application, opening it, RCE. End of the story. No need for the video, but yeah, that's mainly what we did for this iteration of Pwn21. Fortunately, we couldn't make a nice exploit for Xiaomi, and we had a failure, but we learned more things, so, you know, Xiaomi, thanks very much for all the learning we did. That was great. And I think that's the end of the talk, so if you have questions, that's the right moment.
I don't know if it works. Just a quick question. When you're testing stuff on the Xiaomi website, don't you think you're leaking your exploitation components to Xiaomi so they can fix it, especially if you do it before the conference, like peon to on? Yeah.
We got patched multiple times, but they don't look the whole chain. And if they provide users from installing applications during pawn to own, I kind of think they don't really care about this kind of bugs. They care about bad publicity. So yes, technically speaking, but I'm not too afraid.
Hi, thanks for bringing a web talk to this offensive conference. Another quick question: can you maybe repeat why a redirect was enough to include your XSS payload?
So when an URL is loaded inside the web view, every time an URL will be about to be loaded, this callback should override URL loading to prevent people to escape. So for example, on Samsung, if you have the JavaScript bridge that is injected into the web view, you can just browse to another page and it's still injected. So they try to prevent these kind of things from happening with this callback mainly, because it's called every time a URL will be loaded into the web view.
Okay, and so this callback is then triggering the XSS, or was it the intent redirecting?
Yeah, so the intent redirect happens because they extract a parameter from the URL. So we don't really care about the destination. We just care about this parameter being present, because inside the implementation, they're like, is there this parameter, which is called fallback external URL? And if yes, they extract it and they do the intent proxy bug.
I see, thank you.
Sure.
I have two questions. So firstly, when they introduced this file delete thing, did you look at that? If this is maybe vulnerable somehow, that would be kind of funny.
To be honest, no. We kind of just, yeah, I mean, it was like during the contest, and then after the contest, we were like, well, this is a bummer. We're just not going to do this for a while. So no, I haven't looked at it. It's open to anyone else to look at as well, so it could be something interesting there, yeah.
If it's still there. And the second question is, I didn't really understand the click mitigation, like with the physical click mitigation.
So mainly, when you call these install bridges, what you do is you get code execution through the XSS, then you execute your JavaScript payload. So the mitigation is, you have to do a one-click. So first thing, every time you will click on the screen, this callback will be fired. They take the time, and they're like, okay, the first click happened at this moment. Then you have 10 seconds to make another click on your screen, physical screen click. Otherwise, they reject you from installing an application. But because we have only a one click, plus the fact that we are executing JavaScript, we can't simulate it, and yeah, it's too late.
I mean, an idea from me would be just like to start this exploit, and then like call the person.
Yeah. Not really. I mean, maybe. You can play with it. Everything is open source at this point, so go ahead.
All right. Yeah, great talk. Thank you.
Rob, I think that's everything. Thank you.